This is back titration, and you are provided with the following reagent. The first reagent is 2 molar HCl solution A. Then the second reagent is 0.4 molar sodium hydroxide solution B. Then number 3, 1.0 grams of X carbonate labeled as solid C. So my student, in back titration you have been given 3 reagents, and that is the case always. Therefore my student, you will find out that we are going to have 2 reactions that will be taking place in this case. In the first case is a reaction between the carbonate, that is solid C, and the acid solution A. And we know very well that an acid, when it reacts with a carbonate, we form a salt plus carbon 4 oxide plus water. But also the same acid will react with the base, where we form a salt and water only. So it means in this case, this solution A, 2 molar HCl is in excess. Why? Because the acid, first of all, it will react with the carbonate, then the remaining amount of the acid will also react with the base, that is sodium hydroxide, during titration. Let us go back to what we are required to do. So they are saying you are required to determine atomic mass of X in 1 mole of the X carbonate. So let us go to the procedure. So the procedure is as follows. Procedure number 1, you measure 50 centimeter cube using 100 mils measuring cylinder. Then you transfer this solution A into a clean beaker. Then procedure number 2, add all solid C into the content of the beaker, then stir until effervescence stops. So in the first and the second procedure, we are reacting 50 centimeter cube of solution A, which is the 2 molar HCl. Then we transfer into the beaker, and then we add solid C. But you can see in this case, solid C is the carbonate. Then after that, procedure number 3, you transfer the resulting solution into a 250 centimeter cube volumetric flask, and you top up with distilled water to the mark. Then you label this solution as solution D. So solution D is just a mixture of the acid and the carbonate, but we have topped up with the distilled water to the mark. Then procedure number 4, fill the burette with solution B. What is solution B? When you look at what you have been given, solution B is simply sodium hydroxide, whose molarity is 0.4 molar. So the base is in the burette. Then procedure number 5, you pipette 25 centimeter cube of solution D into a clean conical flask. Then you add 2 drops of phenolphthalein indicator. So whatever we have pipetted is 25 centimeter cube of solution D. But remember, solution D has been formed after reacting HCl and the carbonate. Then we topped up with distilled water up to the mark. So my student, after that, procedure number 6, you titrate solution D using solution B. So solution D is simply dilute HCl, then solution B is the base sodium hydroxide. Then you complete the table below. When it comes to the table, titration table, it is showing whatever that was put in the burette. And first of all, every time you will be asked to give the volume of the pipette used, which is 1 mark. So the volume of the pipette used in this case, is equal to 25 centimeter cube. That's the volume of the pipette used. Then after that, you carry out your titration. So let us have the techniques of filling the titration table. When you look at the titration table, we have in the middle we have the initial burette reading, which are given in centimeter cube. Then we have the final burette reading. Then finally you have to find out the volume of B used, that is the base, in centimeter cube. So my student, when you look at this table, you have to carry out 3 titration. The number of titrations are 3. This is the column for the first titration. This is the column for the second titration. This is the column for the third titration. But I've been giving you the techniques on how to carry out and complete the table. So I've been advising my student, because here we are looking for marks. Therefore, it is good that when you carry out the first titration, remember to start the titration, you fill the burette and you start from the 0 mark. Also, the second titration, also ensure you fill the burette so that you also start from a 0 mark. Then the third titration, you do the same. And after that, you will find out that it is good to also observe the rule of decimal places. So my student, ensure when you carry out this one, you use 1 decimal place all through. Or if you choose to use 2 decimal places, let it be consistent. But it is convenient to use 1 decimal place. So my student, that is how you can fill the initial value in both titration, or in both number of titrations. Then, for example, in the first titration, if I started from 0, and in this case, you carry out your titration carefully, then the final burette reading is 20. So you record 20.0. And it is good that when you carry out the first titration, you carry out the second and third. But please, for reasons of consistency, if you want to score a mark for consistency, ensure your values are accurate, and please make it the same. Make it the same for you to be on the safer side. So when you look at the final burette reading for both the first, second, and third titration, they are 20.0, 20.0, 20.0. Then how do you get the volume of solution B used? Always we take that is the final burette reading, then you subtract initial burette reading. So in this case, for the first titration, you just take 20.0 minus 0.0, which is 20.0. Second titration, 20.0 minus 0.0, you get 20.0. Third titration, the same, 20.0 minus 0.0, which is 20.0. Then after you have completed the titration table, you have about 4 marks. decimal place 1 mark, complete table 1 mark, then the principle of averaging 1 mark, then the accuracy 1 mark. So after that, my student, we can now move to calculation, those questions on calculation. And the aim of this titration, my student, is to equip you with the skills and knowledge on how to carry out the calculation, because it is important after you have completed the table. What matters is how are you going to carry out the calculation. So my student, just follow me and please be very keen. At the end of this lesson, you will be able to carry out calculations on back titration. This is just a sample question and it is a dry titration where we don't carry out the real titration, but just to practice on how to calculate and master your skills so that you score all the marks on calculation. So for example, in question Roman 1, from what we have been doing, calculate the average volume of B used. So the average volume of B used, it is here in the table. So you take the 3 consistent values, then you average them, you divide by 3 because there are 3 titration in. Just watch and see. Average volume, you take 20.0 plus 20.0 plus 20.0, then you divide by 3, which is equal to 60 divided by 3, it is 20.00 centimeter cube. And I'm giving in the average volume, I'm giving in 2 decimal places. This is because for accuracy reasons. Then question Roman 2, which is also very important. They are saying calculate the number of moles of HCl, that is hydrochloric acid, in 25 centimeter cube of solution D. Remember, solution D is the one you pipeted from. Look at procedure number 5. You pipeted 25. We pipeted 25 centimeter cube of solution D into a conical flask. So they want you to get the number of moles of that HCl in 25 of solution D. So how do we calculate that? So this is very important, my student, because we are going to use the mole ratios to get the number of moles of solution D, which is the dilute HCl. So when you react sodium hydroxide and dilute hydrochloric acid, you are going to form a salt, which is sodium chloride and water. And when you balance this equation, you will find that the equation is already balanced. So we look at the mole ratio between the base, that is solution B, and the HCl, which is solution D. It is in a ratio of 1 to 1. So this mole ratio, my student, is a must. And therefore, if we can calculate the number of moles of solution B used, then we use the mole ratio, we will get the number of moles of solution D, which is dilute HCl. So in this case, what's the number of moles of solution B, sodium hydroxide? Number of moles is given by molarity times volume all over 1000. What's the molarity of sodium hydroxide solution B? When we come to the what have been given, the molarity of sodium hydroxide solution B is 0.4. Is it okay? Let us come back to that question Roman 2. So to get the number of moles of sodium hydroxide, we get the molarity times volume. Volume of B used, we have calculated from the table. It is 20. The average volume is 20 all over 1000. So if you calculate carefully, you get 0.008 moles. Is it okay? Then we look at the mole ratio between B and D is ratio 1 to 1. So it means moles of B and moles of D is equal. So in this case, it is moles of D in 25 centimeter cube that reacted with the base is equal to 0.008 moles. Is it okay, my student? Let us move to the next question. Roman 3. Calculate the number of moles of hydrochloric acid in 250 of solution D. Remember, solution D was formed after diluting from 50 to 250, and we have only pipetted 25 out of that 50. But in Roman 2, we have calculated the number of moles of HCl in 25, which is 0.008 moles. Is it okay? Therefore, to get the number of moles of HCl in solution D in a volume of 250, it is very simple. So we reason this way, my student. If 25 centimeter cube from Roman 2 above has given us 0.008 moles, what about in 250? So this is what we call cross multiplication, which will give us 0.008 divided by 25 times 250. So this one gives us 0.08 moles. Is it okay, my student? Then we move to Roman 4. Calculate the number of moles of hydrochloric acid in 50 centimeter cube of solution A. So calculating the number of moles in back titration of an acid in the original solution, in that volume of the original solution, which was 50, it is very simple. We just apply the formula. Number of moles is always given by molarity times volume over 1000. But what's the molarity of the original solution that we were given? When we go back there, solution A was the original solution, that's the HCl solution A, whose molarity is 2 molar. So the molarity of the original solution is 2 molar. Is it okay? So let us come back to that question Roman 4. But the volume, the original volume that we measured in a measuring cylinder from the procedure is 50 centimeter cube. So if we apply this, molarity M is 2 molar, then V volume is 50, but all over 1000, meaning in a liter. So if you calculate properly, then my student, you get 0.1 moles. 0.1 moles. So the molarity of the original solution was 0.1 moles. Is it okay, my student? Then let us move to question Roman 5. Roman question 5 says, calculate the number of moles of hydrochloric acid that reacted with solid C, the carbonate. So the carbonate, solid C was the carbonate. So my student, we reason this way. Remember, in the original solution A, in Roman 4 here, the original solution A, that's the volume of 50, the number of moles is 0.1 moles. So that's the original. Before it reacted with the carbonate. Remember, before it is 0.1, the original solution. So it means we ask ourselves, after now the air reacted with the carbonate, it means there is some amount of moles that reacted with the carbonate. That is the moles of the acid that reacted with the carbonate, but we don't know. But the original moles is 0.1. Is it okay? But remember, after reacting with the carbonate now, we found out that after topping up to 250 with distilled water, we have calculated the number of moles in that 250. It is 0.08 moles. So these 0.08 moles are the moles that are remaining. Remember, they are the moles that they are remaining, isn't it, after reacting with the carbonate? But before reacting with the carbonate, my student, the number of moles was 0.1. Is it okay? So how do we get the moles of the acid that reacted with the carbonate? So we take the original mole, which is 0.1, then we minus the moles that are remaining in 250, which is 0.08 moles. Simple imagination and simple subtraction. Is it okay, my student? So in this case, To calculate the number of moles of HCl acid that reacted with solid C, that's the carbonate, it's very simple, my student. We just take the moles at the original 50 centimeter cube volume, then we minus the moles at 250. That is after now the acid has already reacted with the carbonate. Is it okay? So original mole is 0.1, then you minus the remaining moles at 250, which is 0.08. So if you subtract carefully, you get 0.02 moles. Is it okay, my student? Then let us move to question Roman 4. Calculate the number of moles of the carbonate that reacted with the 50 centimeter cube of solution A. Remember, solution A was the original solution of the acid. So my student, it is simple. Let us look at this equation. Remember, I told you in back titration, equations are two chemical equations, or two reactions are taking place. So in this case, X carbonate and the acid, you get a salt, which is X chloride plus carbon dioxide plus water. This is form 1. This is form 1. This is the knowledge from form 1. Then my student, if you write this equation carefully, let us check on the mole ratio between the carbonate and the acid. So if we have balanced the equation, you find out that the mole ratio between the carbonate and the acid is 1 to 2. The mole ratio is 1 to 2. How? Look, here on the carbonate, it is just 1 mole of the carbonate reacting with the 2 moles of the acid. So the mole ratio is 1 to 2. So my student, remember, in Roman 5 here, look at Roman 5. We have calculated the number of moles of the acid that reacted with the carbonate solid C. So if we know the number of moles, look, this HCl, we know its moles. So to calculate the number of the carbonate that reacted with the acid is very simple. We use the mole ratio. My student, hope you are getting it. It is simple and clear. Therefore, do we know the number of moles of the acid that reacted with the carbonate? Of course, yes. Look at Roman 5. It is 0.02. So to get the number of moles of the carbonate that reacted with the acid, we reason this way, using the mole ratio. So the ratio of the acid is 2, which is giving us 0.02 moles. What about ratio 1, representing the carbonate? So that's about cross multiplication. So we take 0.02 divided by 2 times 1, which is equal to 0.01 moles. Is it okay, my student? Then we move now to the last question. This last question, my student, they are saying you calculate the mass, that is the atomic mass of X. Calculate the atomic mass of X in 1 mole of the X carbonate. But remember, in the brackets you have been guided, or you have been given a hint. That is the relative atomic mass of individual elements in this carbonate. For example, carbon is equal to 12, oxygen is equal to 16. So my student, they want you to calculate the value of X. So in this case, we apply this formula. There are two formulas that will be involved here, where we say molarity is equal to concentration in grams per liter all over RFM. So we want to calculate the RFM. It is the RFM that will enable us to get the relative atomic mass of X. Is it okay, my student? But now, do we know the molarity? No. So let us calculate the molarity and also calculate the concentration in grams per liter before we calculate the RFM by making the RFM the subject of the formula. Is it okay, my student? But concentration in grams per liter, how do we calculate concentration in grams per liter? It's very simple. Remember, the mass we have been given of the carbonate, it was 1.06 grams. But this 1.06 gram was dissolved in 250 of distilled water. Is it okay? So we ask ourselves, how do we change this concentration from 1.0 grams in 250 into grams per liter? Very simple. So if 250 is giving us 1.06 grams, what about 1000? That is 1 liter. Is it okay? Cross multiplication. 1.06 divided by 250 times 1000, which is equal to 4.24 grams per liter. So we have calculated our concentration in grams per liter. Is it okay? What's remaining is now the molarity. How do we get the molarity? Remember the formula that says, another formula. Molarity is equal to number of moles times 1000 all over volume. Is it okay, my student? So molarity, how do we get the molarity? Number of moles of the carbonate that reacted with the acid in Roman 6, it is 0.01. So the number of moles of the carbonate is 0.01 times 1000 all over volume. This carbonate was dissolved in a volume of 250. So if you calculate carefully, the molarity of the carbonate is 0.04 molar. Is it okay, my student? Now if we come back to this first equation, molarity is equal to concentration in grams per liter all over RFM. So we make RFM the subject of the formula from the point of mathematics. So it means to get the RFM is equal to concentration in grams per liter all over molarity. So what's the concentration in grams per liter? It is here we have calculated is 4.24 grams per liter, which is 4.24 grams per liter. Then what about our molarity? We have calculated here, you can check and see, it is 0.04 molar. So if we divide the two, RFM is 106. Please take your calculator and check and confirm, my student. Is it okay? Good. Then finally we want now to calculate the value of X, the atomic mass of X in this M carbonate. Is it okay, my student? How do you go about it? So if you take individual relative atomic masses, you add them, then you equate to the RFM. Is it okay? Let us do. So this means X are 2, so 2 times X plus carbon is 1, which is 12. That is from the brackets here. Carbon is 12, oxygen is 16. Then how many oxygen are here? In this carbonate there are 3. So it is 3 times 16. Each oxygen is 16. You equate to 106. Is it okay, my student? Then this becomes 2x plus 12 plus 48 is equal to 106. 2x plus 60 is equal to 106. 2x is equal to, we take now 60 to the other side. So it becomes 106 minus 60. So 2x is equal to 46. Is it okay? That is 106 minus 60 is 46. Then 1x is what? 1x is equal to 46 divided by 2. Then x is 23 grams. So this 23 grams, this relative atomic mass of X. So which element has a relative atomic mass of 23? This is sodium. This is sodium. So what does this mean? Let us come here, my student. Let us come to the top. It means this X carbonate solid C was sodium carbonate. Is it okay, my student? So at the end, you have realized that when it comes to back titration, my student, we have 3 reagents: the acid, the base, and the carbonate. But remember, the acid is always in excess. Why? Because first of all, it will react with the carbonate, then the remaining amount is the one that reacts with the base. So my student, this is Mr. KW. You can subscribe into my channel for more and more sample questions, especially the candidates preparing for their KCSE exam. Thank you for watching.